Okay, in Lab 9, we're going to cover a very important topic, but which we didn't get a chance to cover during the lecture, is the life of a delta. So we all know a delta is built by sediments brought by the river introducing to the coastal area and start to accumulate and develop a fan-shaped deposit. This is based on that the river has enough of sediments to deposit over here, and the depositional rate has to be higher than the rate that the wave and the longshore current can redistribute the sediments. So it is natural that the sediments come to the coastal area and be redistributed. However, when a river brought by a sediment and start to deposit over here, the topographic slope in this area gonna be more and more gentle. So as the slope steepness decrease, it is becoming harder and harder of the river to push sediments into this area. So it is natural that the river wants to switch the channel to other area to find a place to deposit the sediments. And for example, in the Mississippi River, it is very likely the Mississippi River gonna switch the channel to Atchafalaya River and deposit sediment over here. And what will happen to this Mississippi Delta is that without continuing supply of sediments, this delta gonna shrink, and all the sediments over here will gradually be redistributed to other area along the shoreline, and this Mississippi Delta gonna keep shrinking and eventually disappear. So this is a life of a delta. It happens to all the delta in geologic record. And here in Mississippi River, at the beginning, Mississippi River brought sediments to the Mississippi Delta, and the Red River actually is also contributing to the Mississippi Delta. However, as the Mississippi Delta growing larger and larger and the topographic slope is decreasing, the river is trying to go find a new path, easier path to contribute sediments. So then sedimentologists found that the Red River actually is starting to switch its channel to Atchafalaya River. They found in the Wax Lake Delta is receiving most of the sediments from Red River, and they also found that this Wax Lake Delta is also receiving considerable amount of sediments from Mississippi River. It is natural for the rivers to make such decisions. However, we cannot lose the Mississippi Delta because there are people living on the Delta Plain nowadays, and the New Orleans city is built on top of the Delta Plain of the Mississippi Delta. So when people are trying to keep the Mississippi Delta here, the first thing they tried to do is that to dug a channel for Mississippi River and let the river going this way. But this didn't work. After years, they still found that the Wax Lake Delta is receiving considerable amount from Mississippi River, and this portion of sediment is keep increasing and increasing. So then what they are trying to do later, they build dams along these two places to stop the water going to this way. However, the trouble is when a river does not want to go this way, it has a reason, and this is infrastructure caused the flooding of the Mississippi Delta area, the Louisiana coastal area. The flooding issue here is very bad. So they made this structure can be open during the flooding seasons. So when lower stream is in danger of flooding, they will open these two dam structures and let the river flow this way. This didn't really help with the flooding situation, but that's the situation for now. And another thing is flooding issue in the lower Louisiana area is really bad. And on top of that, the upper stream of Mississippi River start to have floods more often compared to previous flooding record. So in this lab, we are gonna use a satellite image and digital maps to study the size changes of Wax Lake Delta and to see how does these constructions of river control system has influenced the size of the Wax Lake Delta. Okay, so in this lab, to study the delta size change through time, you need to make 3 types of measurements. Those are the width of the delta, the length of the delta, and the tributary spacing of the delta. And for these 3 types of measurement, you need to do that for 7 times for delta map of years of 1947 to 2002. There are 7 maps, and you need to make the same 3 types of measurements and fill those data into the 3 tables provided in the lab. Okay, so now I'm going to show you how to make those 3 type of measurements. The first is the width of the delta. Actually, it is a circumference of the delta. So I'm using the map of 1990s as an example. This color is not exactly the same as the original copy. I don't have a color printer, so I color these delta with color pencils. Okay, so the point of the color is that you can differentiate the different sediment lobe from each other. For example, in this one, even though there's one major tributary in the center, I still know that this lobe and this lobe actually originally they are the same lobe and then develop a new major distributary in the middle. The places where I colored are delta plain area. On the color map, they are the darkest color. And in this lab, we are only making measurement on those areas. And they are darkest color with a solid line of the outlines. To measure the circumferences, we need to find the furthest point of the delta plane from the apex. So on this map, this point is the river mouth, and then to this sediment lobe, this point is the furthest point. And on here, this is the one, and on this this lobe, this is the one. Okay, I think I'm gonna use a circle to be consistent, and this is the lobe as well. And on this one, this is the furthest point. This one, I would say this one here. And it's here, here, and here. Okay, so you can also consider as this entire lobe as a 2 parts. So let's draw here as 1, 2. Okay. And maybe add another one. So it doesn't matter if you add more because we are drawing a circumference. Okay, so from here, this outline of the delta plane, we can draw an outline of the delta plane this way. Just connect the dots we have picked, and maybe here we can add another one. Here, I use a straight line to connect those dots of the furthest point of the delta plane. This is an estimate of the circumference of this delta. And the next, we're gonna measure the length of the circumference of the delta. Here, I'm just gonna use my ruler and the zigzag through the way. This point, that is a 2.5. I use it. I put my ruler at 2.5 again, and this is about 5, and this is 5.5. 5.5. The next one is 6.5. 6.5. The next one is 7.6. 7.6. The next is 9.3. 9.3. The next is 13.2. That's 16 centimeter. So the circumference is 16 centimeter. So remember, enter the data to the table. We're asking for kilometers. And here on this map, the scale is one centimeter on the map is 1 kilometer. So we had measured this circumference is 16 centimeter. To the map, we're gonna enter the data as 16 kilometer. So on table 1, year 1990, we're gonna have 16 kilometer as the width of the delta. And that's how you make the measurement of the width. Then the next we're gonna make the measurement of the length of the delta. So the length of the delta is from the river mouth. You draw a straight line to the furthest point of the delta plane. You picked from the first step. So you draw this straight line and make a measurement. That measurement is 5.5. So this is table 1. And then table 2, your measurement is for year 1990. And then they ask for measurement 1, 2, 3, 4 to measure 7. Your measure 1 will be 5.5 centimeter. And that is equivalent to 5.5 kilometer on the table. So you put this number to the table, and that's the first measurement. And then you connect to the river mouth to the second sediment, to the second lobe. You pick the furthest point. Connect to that, you make another measurement. That's your second measurement. So you at least you should make 7 measurements for the delta. And if you don't have 7, there are times that this delta is small and you cannot make 7 measurements. You just leave it blank. It's okay. The third measurement you need to make is the spacing between the major tributaries. We know that the delta plain actually are mouth bars. So if this is a mouth bar, that means on the both sides there was major tributary. So on this delta plain, then this is a major tributary and it intersects with the outline of this delta plain over here. And on this side of this mouth bar, there's a tributary, and this tributary intersect with the outline of the delta plain at here, this place. And the distance between this tributary to the adjacent one is from here to here, the space between here and here. So you only measure the distance of the tributary that is the adjacent one. You don't need to measure the distance between this one and this one. You only pick the one that is adjacent to the one you are making measurement from. And another thing is you only make measurement for the major mouth bars. For example, in this sediment lobe, I'm picking the one from the middle, and I'm considering this is one river mouth bar. The distributary I'm picking is this one and the one on the other side of the river mouth bar. So it is this one. you don't need to pick the one that's such as, for example, from here, you can consider this small portion as a river mouth bar, and the channel is from here to there's one channel and there's another. You don't need to measure the distance between this one and this one and this one. So to be said, just pick the major ones and make the measurement from the one to the adjacent one. And in this case, one measurement I can make is from here, this point to this point, and the measurement is 2.2 centimeter. So for table 3, it is 2.2 centimeter, and that's my measurement 1 for year 1990, and that is equivalent to 2.2 kilometers. Okay, just make it easy to read. This is 2.2, and this is 5.5, and the 16 is the one that all these lines adding together as the circumferences of this delta plane. So that's the measurement you need to make for 7 maps. Another thing I want to remind you is that this scale varies from map to map. So every time you make a measurement on a map, you need to refer the scale on the map. You cannot assume that the map in 2002 gonna use the same scale as this one. After you making the measurement, you can plug your table into Excel and make figures to show how this delta has grown and to see how does the size of this delta gonna change through time, and related to just read the material from the beginning so that you know that what year there were constructions and how did the construction affect the size of this delta.